In this video, we're going to take a look at how to save data to the user's device from your app. And to do that, we're going to be building an app that lets you take notes. So you'll be able to browse a list of notes that you've taken, create new notes, type something out, and then persist that or save it to the user's phone. So if they quit your app and reopen it, they can have all of their data still there. So let's get started. To persist data to the user's device, we're going to use something called SQLite. So SQLite is a really simple database that works by saving everything into a file with a special format. And then from that file, you can run SQL queries on it, just like you could on any other database. So to start, let's quickly take a look at a few of the different types of queries that you might write. The first one is a create query. So a create query is used to create a new table in the database. So when you write a create query, you're going to specify the name of the database you're creating, the columns in that database, and the types of each column. So here's an example of a SQLite create statement. We're going to start by saying create table. Then we're going to say if not exists. And that just means if there's already a table there called users, just don't bother executing this because we're already done. Then the name of the table, so users. And then in these parentheses are the names of the columns. So we have one column here called ID integer. So that means that the name of the column is ID, the type is integer. It's our primary key. So that means it's the unique thing that identifies each of our rows. And it's auto increment. So that just means that every time a new row is inserted into the table, we're going to take the ID of the most recent row and add one to that. So this will basically be sequential as you're adding rows to the database. Our other column is a text column. It's called name, and because its type is text, it allows you to insert any arbitrary length text and store that as a string. After you've created a table, you might want to run an insert query. So insert, as its name suggests, is going to add rows to a database table. To write an insert query, we're going to say insert into, followed by the name of our table, which is users, and then in parentheses, the names of the columns that you want to specify values for. So in this table, we just had one column called name, so we'll have that. Then we have the word values, and then again, a comma-separated list of all of the values that we'd like to insert. So here we're inserting a single value of Tommy. After we've inserted rows, we might want to read them back from the database. So to do that, we're going to use a select query. So we can say select star, which means select all of the columns from the table. If we wanted to, we also could have given a comma-separated list of columns we wanted to read. Then we'll say from and the name of the table. So here the name of our table is users. And then we'll have a where clause to filter down the rows. So we only want to select those rows where the name column is exactly equal to the string Tommy. And so if we just have that one row in our database, this will return us that one row. If there are multiple rows with the name of Tommy, it'll return multiple rows. We also might want to update rows in our database. So we could say update, followed by the name of that table. We could say set name equals value. So we're going to set the name column. We're going to use a value of Tommy M. And then we'll have another where clause to filter down the rows we want to update. So we can say where the name column is equal to Tommy. So again, this is not going to update all rows. It'll just update the rows where that where clause applies. So let's jump right into it. Now that we have some basic SQL queries ready to go, let's learn how we can use them in our app. So let's open up Android Studio. And just like we do every time, let's start a new Android Studio project. Select Empty Activity, because we're going to be writing everything ourselves. Click Next. And the name of our application will be a little less clever this time, and just call it Notes. Remember, package name is just whatever you want. We're using the CS50 domain backwards. Save location wherever you want. Make sure language is Java. Choose your minimum API level, and make sure Use Android X is checked. And now click Finish. All right, we've seen this a few times before now. We know the code that's generated. Move this over. And so now, let's, as we did last time, let's start with the views. Let's sketch out the views that our app is going to have. Then let's take care of any necessary models. And then let's write the controller that wires everything up. So our app is going to have two screens, or two activities. The first one is going to be a list of all the notes the user has on their device. And the second one is going to be a screen that lets you edit a note and save it back to a database. So let's write that first activity first. Because it's a list of notes, that says we should probably use a recycler view. So let's do that. Let's open up our main activity XML. And just like we did last time, we're going to add a recycler view. But before we can do that, remember we have to add recycler view to our project. So let's open up build.gradle. Add as our implementation, we had AndroidX.recyclerView. Name is recyclerView, and the version was 1.0.0. And we'll sync this. So it looks like our sync was successful, so now we can use a recycler view in our layout. So let's come back here, and just like we did last time, let's replace this text view with a recycler view. So we can say AndroidX, recycler view is going to autocomplete for us. We can say match parent, again, just like that. And now, just like before, we have this full screen recycler view. So now we've added a recycler view to our layout. Next, we want to create an adapter. Just like we did last time, the adapter was used to manage the data that's displayed in the recycler view and define how that data could be displayed. So let's create a new class. We'll call it Notes Adapter. No need to specify anything for now. And we've created a new class. The other thing we need to do is create a new layout. And that layout is going to define what each row looks like. So we can actually use a layout that was pretty much identical to the last one. So we'll call this our note row. Tap OK, come over here to text, and let's just do exactly what we did last time. The first thing we did was we added an ID, and we called this our note row, and then we added a text view. Again, we had match parent on the width and wrap content on the height, and then we gave it an ID so that we could access it later. And let's just call this note row text. And that's it. Hopefully all of this looks really familiar. It's pretty similar to what we did last time. Now let's open up our note adapter class, and we want to extend our recycler view dot adapter. And then for the type, we're going to create a new class in just a minute called notes adapter dot note view holder. All right, so let's create that class, public static class note view holder. And just like last time, we're going to extend the recycler view holder. We're going to give this a constructor. We're going to say note view holder. Constructor is going to take some generic view, call that view. And then just like before, let's add in those fields for our container and our text view. So we had a linear layout to represent our container view and a text view, a text view that represented our text view. We'll call super on the constructor to make sure that we use that super class's constructor. And then we'll save references to container view. So that's going to be view.findView.id. We had an ID of note row, and our text view was view find by ID note row text. So that's it for our view holder. And now remember, there are three methods that we have to implement. We have to implement binding a view holder, creating a view holder, and getting the number of items in the list. So first, let's handle creating views. So we'll have on create view holder, let autocomplete do a bunch of stuff here. And just like before, we're going to say our layout inflator from that context object. And then we're going to call inflate, and we're going to pass in that layout, r.layout. This time we called it note row. It needs a parent, and we don't need to worry about this other behavior, so we'll just pass false. And now we can just return that. So we're going to return our note view holder on that view. So that's the view that it's going to hold. So now we need to think about our data. The next two methods we need to implement are binding the view holder and getting the number of items. So it's a good time to think now about our model. So just like last time, we know that we want to create a model that represents a note. And each note will probably have some unique ID. That makes sense. And then the contents of the note can just be a string, since those can be arbitrarily long. So let's create a model for our note. But this time, we're not just going to create a regular Java object. We're going to take advantage of Android's SQLite library. So first, let's take a look at the documentation for that. Android's library for persistence is called Room, and it has some nice guide here on how to use it. So you can feel free to read through this, or we're going to walk through it together. So the first thing we need to do is add Room to our project, which, as you probably guessed, is just using a Gradle file. So let's just copy these two things here. Again, we want these two lines to load in everything. So we'll jump back to our Gradle file, paste these in. So for Room version here, I'm just going to use the latest stable version, which is 2.1.0. Just got that number from looking at the documentation. You'll notice here that instead of implementation, this second line says annotation processor. What's going to happen is we're going to use something called Java Annotations, which is just like that app override thing that we added before, that annotation before a method. Now these annotations are going to be used to map fields in some Java object to columns in a SQLite database. So basically, to get access to those annotations and to make sure the compiler can use those annotations to generate code, we just need to add in this annotation processor. But I didn't really need to do anything fancy there. I just copied that right from the documentation. So let's sync our Gradle project. Everything looks good there, so we're good to go. So let's start by creating a new model class. So we'll say new Java class. We'll call this note and press OK. Now here is where we're going to do a bunch of magic using the Room library. So let's define two fields on this note class. Let's call one ID, and that's just an integer. Let's call the other one contents, to be the contents of the note. So now we're going to add a few annotations provided to us from that Room library. So for this first field, we're going to add the annotation primary key. You can see this was imported by this Room library. And for the second field, we're going to add this annotation called column info. And this specifies that this is another column in our database. Now, annotations can also take arguments. And so this one takes an argument called name. And we're just going to name it contents. It's the same thing. If you had a column name that was different than this field, that's where you could specify that mapping. Now, the last annotation we want to add is this entity annotation. And so this says that this class represents a table in my database. And with its arguments, I can specify the name of my table is notes. So this will create a SQLite table called notes with two columns, a primary key integer auto increment column called ID, and a string column, which corresponds to a text column in SQLite 3 called contents. And so now this is really cool. We're just mapping each row in this database automatically to one of these model objects. And that's really going to simplify the amount of code we have to write in order to read and write from this database. So now that we have our model class done, let's go ahead and use that in the adapter. Just like we did last time, let's create a list of note. We'll call it notes, and initially let's just have it be an empty list. So now we can implement that onBind viewHolder method. So just like we did before, we can use this position parameter to get a note. So we'll say note current is notes.get position. And so now we just want to set the text of this text view to be the text of the note. So let's say I have my holder dot text view, and we'll set the text to be current dot contents. Pretty simple. Lastly, let's define a method to get the number of notes inside of the adapter. So that's going to be my get item count, and just like before, let's just return notes.size. Okay, so this is a pretty simple version of the adapter. It doesn't do too much yet, but it's some good boilerplate. And I have this red line here, forgot to say new, so that's going to fix that compilation error. So now, just like we did last time, let's add the necessary classes to our main activity. So we need a few things. The first thing we need is a recycler view, and we can just call that recycler view. The next thing we need is an adapter, so that can be our notes adapter. And the last thing we need is that layout manager. Now, inside of onCreate, we're going to grab and instantiate these objects. So recycler view is going to be find view by ID. Oh, looks like we forgot to give that an ID, so we can come back. Autocomplete let me know I forgot. And so we'll just say Android ID is recycler view. So now autocomplete should be good, and it is. That's our recycler view. Remember layout manager, we can just say it's a linear layout manager, give it access to some activity. And then our notes adapter didn't take any arguments in the constructor, so we can just say new notes adapter. Finally, we can set these values. So we can say recycler view, set layout manager, and recycler view dot set adapter. So all this should look really familiar. We're just grabbing that recycler view from the layout, and we're configuring its layout manager, just laying things out straight in a line, and we're configuring its adapter, which is a new instance of that adapter that we just wrote. So right now, if we were to run this, it wouldn't be a terribly interesting app because we know our recycler view is going to be empty. So now let's go ahead and take care of writing all of the model code that's necessary to do three things. The first is creating a new note. The second is getting all the notes that a user has already created. And the third is saving a note to disk. To do that, we're going to write a new class called a DAO, or it stands for Data Access Object. And again, we're going to use this room library that Android provides to really easily map methods to queries that we're going to run on the database. So let's do that. Let's create a new class to represent our data access object. So we're going to say new Java class, and we're going to call this a note DAO. Click OK. So if you read through the room documentation, what you'll find is the way that this works is we're going to write not a class, but actually an interface. And we're just going to annotate the methods in this interface with some queries. And then under the hood, the room library, while everything is compiling, is going to generate some classes for us. So essentially, the compiler is writing some code for us so we don't have to. So to start, let's change this class to an interface and add the first annotation, which is a DAO. So we've specified this is a room data access object, and so now the room library is going to do something with this interface. First, let's specify a method for creating a note. Now, we don't need to pass any arguments to this method because we're just going to create a note with some default values. So now to specify the SQL query that's going to be run when you have this create object, we're going to specify @query. Again, this is another annotation from the Room library. And here is where we're going to write our SQL. So we're going to say insert into notes, just need the contents, values, we'll just say new note. And that's the default value for one of our notes. So now what's happening here is we're going to generate some code, and whenever this create method is called, this SQL query is going to be run on our database. So let's do the same thing to implement those two other methods. The next one we can implement is the method to get all of the notes in the database. So that's going to return a list of notes. And we'll call this method getAllNotes. And again, let's use this @query annotation to specify the SQL query we want to run. So we want to say select star, just grab everything from notes. And that's it. That's a SQL query that's going to say, give me all of the rows in the database and grab all of the columns for those rows. So that was pretty easy. So last, let's write the method to save notes to our database. So return type will just be void because we're not returning anything, we're just writing something to disk. And let's call this method save. Now this method, unlike the other two, requires a couple parameters. Let's call one contents, and let's call the other ID. And this makes sense because in order to save something to the database, we need to pass in the value to save, and then also the ID of the note that we want to save it to. So we can actually use the values of these parameters inside of our annotation. So we'll say @query, and then we'll write our update query. We're going to say update notes set contents equal to :contents, where ID equals :ID. So this is taking advantage of a SQLite feature called parameter binding. So this says wherever I see that :contents, I'm going to replace that with the value of the variable that's inside of this method declaration. And same with ID. So I don't really have to do any kind of fancy string interpolation. And this is also a much safer way of getting user input into the database. If you're just manually concatenating strings, you're opening yourself up to different types of attacks. And so this is just a really safe way of making sure that you take some user input, like the contents of a note, and use it in the context of a SQLite query. So this is it. This is actually our entire data access object. Interestingly, we didn't have to write any lines of code to manually save something to the database or open a file or anything like that. We also didn't need to write any code to convert some kind of row object to some kind of note object. All of that is taken care of by this Room library. What we did have to write, though, was the SQL that we want to be executed when you call these various methods. So that's it for our note DAO. We have to write one more class in order to use this. And that class is called a database class. So let's, just as we did before, let's create a new class. Let's call this our note database. And here, as you probably guessed, we're going to use some more annotations provided to us by the Room library. So the annotation we're going to use for this class is the database annotation. So the database annotation specifies that this is the database, or sort of the entry point for all of the data access objects that your app is going to use. So we can see here from our autocomplete that this annotation takes one argument called entities. And here we can specify a list of all of the data access objects that we need to use. So we just have one, which is our note DAO. And we're going to use this dot class syntax to indicate that we're specifying and passing in a class. The second argument to this annotation is a version number. In case as let's say you release an app and you're sort of changing the database schema and you want to version it, you can just specify a version here to let Room know when you have a different database schema. Okay, so that looks pretty good. Now we're saying that inside of this database, we have this one data access object that we can use to get different values. So now let's move on to this class. The first thing we want to do is extend our Room database class. And so this is a base class that's going to specify a bunch of different methods for us. And one other thing we want to do is add this keyword abstract to this class. So an abstract class is somewhere between a class and an interface. In an abstract class, you can have some methods that have bodies and definitions, and you can also have some methods that don't have any bodies. And when you extend an abstract class, you have access to all of those methods that are defined and have a body, and you're required to implement these other methods that are marked as abstract. So you can think about it as sort of a combination. It's like an interface that requires you to sign this contract to implement some set of methods, but like a class, it also has some functionality already, so you can call some other classes. So by saying abstract in front of a method, that's how you indicate that this isn't something that I'm going to implement myself. Instead, this is something that's going to be implemented by somebody else. So we're going to add one abstract method to this class. We're going to say public abstract noteDAO, and we'll just call it noteDAO. And so the reason that this is abstract is because, again, this Room library, when you're compiling these files, it's going to generate some code for us. And so the class that implements or extends this abstract class is going to be generated by the Room library. And with this @database annotation, that's what's going to tell the compiler, let's go and generate some code that can be used. So we're not actually going to have to implement any of this ourselves. It's this Room library that's writing the code for us. So now that's all of the model code we're going to have to write. Let's just quickly recap what we did. First, we defined our note class. And our note class is where we defined what our data looks like. We said we have a table for notes, and each entry in that table has two fields. One of it is a unique identifier, that's an integer, and the other is a string that contains some contents about the note. So this defined our table. After we defined our table, we defined a way to access that table and sort of interact with the table. And we defined three methods to do that. We defined a method that runs an insert query to add values to the table. We defined a method that runs a select query to get data back from the table. And we defined an update method to save data that's inside of the table. Last, we created this database class that basically collects all of the data access objects together. In our case, we only have one, and so we listed it here in our annotation, and then we created one abstract method that someone else is going to implement for us to get access to an instance of that data access object. So now that all of our model code is written, let's take a look at how we can use that model code in our application. So first, let's jump back to that main activity. So first, let's define an object that's going to represent a connection to this database. So I'm going to create a new static field on my main activity. Its type is notes database, and I'm going to call it database. And the reason I'm making this static is because I want all the different activities in my app, in this case there are only two, to use the same instance of a database. And rather than passing that around constructors everywhere, I can just make this static, and then other classes in my app can use it. So once I've defined the field, let's set its value to something. So I'm going to say room.databaseBuilder. This takes a couple arguments, it looks like. The first argument is a context. We saw before that there's just some global context object we can use. The next argument is going to be the class name for our database. And that's our notesdatabase.class. And finally, we want a name. So that's sort of a string name for our database, and that's the file that we're going to save on disk. Let's just call that notes. The next thing we want to do is just allow our database to run on the foreground. So normally you'd want to sort of do heavy database queries and some kind of background task. We're not going to worry about that, so let's just say allow this to happen on this sort of main foreground task. And finally, we're going to call build. And so this is going to give us back a database that we can use. So let's use this new object. Let's jump over to our notes adapter. And let's create a new method on this adapter to load everything from the database. So we'll just call this reload. So inside of our reload method, let's first set the value of that notes field. And so we can say main activity.database. Remember, we made database a static field, which means that we can access it by referencing this main activity class. So say main activity.database.noteDataAccessObject, or noteDAO, and that's a method that we defined. And then we can say get all notes. And this is going to call that method from the noteDAO, run that select query, and give us back a list of notes. Now, just like last time, we have to call notifyDataSetChanged, and that's going to tell the recycler view that we've just updated that underlying object, reload yourself. So now that we've written this method, let's use it. Let's come back to our onCreate and call adapter.reload. And this says when the app runs, the first thing it's going to do is go to the database, grab everything, and display it in the recycler view. So now we have a mechanism for reading notes from the database, but we don't have a way to create new notes. And if you remember, our UI doesn't have any controls or buttons to do that either. So let's add a button to this activity that when we press it is going to create a new note. And the class that I'm going to use is this class that's given to us by Android called a floating action button. This is a pretty common Android pattern. You've often seen, a button sort of on top of a list, and you can tap that button and something happens. So that button is defined in, again, a separate library that we need to pull in. So let's do that. And the name of this library is com.google.android.material. So the name of the library is material, and the version is 1.0.0. So this is just another class. It's provided to us by Android, and it contains a bunch of other UI elements we might want to use. And so let's just pull those into our project. So now that we've downloaded this library of material UI components, let's use them in our app. So let's jump back to the layout for our main activity. So the first thing we want to do is change the layout that's used here. And we want to pick a layout that's going to enable that floating action button to sort of float on top of the recycler view. So we're going to change constraint layout to something else. We're going to use what's called a coordinator layout. And this is just basically a different type of layout that's going to allow us to do what we want. So after we've changed that, let's come back over to here and add a floating action button. So just like before, let's specify a few of those attributes. So we have our layout width, and let's just have these both be wrap content. So that's our width. That's our height. Let's give this button an ID, just so we have it. We have @+ID, and we have, let's just call this add note button. After we give it an ID, let's specify where we want it to float. So let's add our button to the bottom right of the screen, since that's kind of a common place to put it. So let's say Android layout gravity is going to be in the bottom right. And we don't want it to be all the way on the bottom right, so let's just give it a little bit of padding. So we'll say Android.layout margin. Let's just say 16 pixels. That probably looks pretty good. So the next thing we want to add is an icon to our button. And luckily, Android provides a bunch of default icons that we can use so we don't have to add our own or create our own icon. To do that, I'm going to use this app source compat attribute. And I'm going to start by saying @Android. And then here you can see there's a bunch of stuff supplied already. So if I start typing drawable, I can see a bunch of icons. So I'm going to use this input add icon. And so this is just a little plus. It basically says this is the system icon that you should use if you're having a plus button or a button that adds something. And we do because we're adding a note. Last, let's give our button a color. So we're going to say Android Tint. And you can start by saying @color. And again, there's a bunch of colors here that are listed. I'm just going to pick this one, sort of a background color for a light background. So that's everything with our floating action button. So now we've styled this pretty nicely. So now let's build our application and make sure there are no errors. So let's come up here to build. Yep, looks like we have an error. So let's jump over here. Looks like there's some kind of problem with our database. So let's come over here. And yeah, here. So rather than doing the data access object, we want to use the entity. So recall that note is what we decorated with the @entity annotation. So we just want to make sure that that's the note, not the note data access object. So now if we rebuild, now we've compiled successfully. So let's run the app and just take a look at what this floating action button looks like. Looks like we've installed successfully. So let's pull up our emulator. That looks pretty nice. So we have a recycler view here. It's empty because we haven't created any notes yet. Now we have this nice button over here that when we press it, doesn't do anything. So let's hook up an action to this floating action button. To add an action, let's jump back to our main activity. And then on create, let's grab that floating action button. So we'll create a button object. And we'll set this equal to find view by ID. And we called this add note button. So with this button object, we can call that same method we called before, which was set on click listener. And this took one argument, which was a view dot on click listener. Let's see if we can get the autocomplete here. There we go. And so remember, we're just overriding this one method called onClick. And so when we click this button, we want to do two things. The first thing we want to do is create a new note. So let's get that note data access object just like we did last time. Say database.noteDAO. This time we're going to call create. And that's going to create a new note. Next, let's reload the adapter. So let's call adapter.reload. And that's going to tell the adapter that now that we've created a new note, let's refresh the recycler view so that we can see it in action. So let's try this out. Let's run this app. Here's our emulator. Let's give our action button a click. And there we go. Here's a row that represents our new note. The contents of this row are the contents of the note, which is just new note. So we're off to a good start. Next, let's hook up a new activity to display the full contents of a note and enable the user to change it. So remember, to do that, we're going to come over here to the left. We're going to say new activity, and we're just going to create an empty activity. And we're going to call this our note activity. All right, so that created a Java class and a layout. Let's go to the layout first. So here, let's just create a really simple edit text. So edit text is actually a subclass of text view. And as its name suggests, it's editable instead of just being a read-only list, string of text. So let's just set this to be the entire width of the screen. So we're just going to match parent on both of those. And then let's set an ID because we know that we're going to need to access that later. So we'll call this note edit text. And that's it. So now let's open up that new class that was generated, this note activity. As we always do, let's create a field here for this edit text. And let's grab a hold of it in onCreate. OK, so we want to do two things. When this activity is created, we want to set the text of this edit text to be the note that's in the database. So that way, when we open this up for the first time, the user just sees what was there before. The other thing we want to do is when the user leaves this activity, we want to save the current contents of that edit text back to the database. So let's do those two things. So now that we have a reference to this edit text, let's set the contents to be the contents of the note the user selected. To do that, we're going to do just what we did last time. We're going to use an intent to pass the contents from one activity to the other. So let's assume that our intent has defined something like contents. We'll say string contents is get intent dot get string extra called contents. So now we'll just set the text of the edit text to be those contents. So that's loading the note. And the other thing we want to do is to save the note. So to do that, we're going to use another method called onPause. So where onCreate is called when the activity is first created, onPause is going to be called when you leave the activity. So just as before, let's make sure we call super. And so now we want to use that database notes DAO to save the contents to disk. So let's just save the ID of the note that this activity represents in a field. So we'll say private int ID. And let's just use the intent to store that. So we'll say ID is getIntent.getIntExtra. And we'll call that ID, and we'll just give it a default value of 0. Now, in onPause, we can use that same database object. So we'll say main activity, database, note DAO. And now we're going to call save. And remember that save takes two arguments. The first one is the contents of the note. The second one is the ID of the note. Contents of the note, that's going to be from the current text field. So that's going to be edit text dot get text is going to get me the text that's currently in there. And then we just saved the ID, so I can just call ID right there. So now this says before this activity is closed, when the user hits that back button, let's persist everything that we have to disk. So now let's write the other half of this interaction. So let's come back to our notes adapter. And just like we did last time, we want to attach a click listener to the container. So we're going to say container view dot set on click listener. Let the autocomplete generate that for us. So this is going to feel pretty familiar. We want to create an intent. We want to set the ID and the contents extras field of the intent. And then we want to start the activity. So we need to make sure that this view holder has a reference to the note. So to do that, remember what we did last time. We said holder, container view, and we used this set tag method. So we'll pass along the current note right there. Now we can say my note, current note is going to be my container view dot get tag. Remember, we just have to cast this to a note because this is just a regular object by default. OK, so now let's create our intent. Remember, the way to do that is by creating a new, first make sure we're importing it, create a new intent. And the intent is going to take a couple of arguments. The first one is that context object. And the second one is the class that we want to use. That's going to be noteActivity.class. Now, using that note object, let's put in those extras. Let's say intent.putExtra. We have the ID of our note, and that's going to be current.id. And we have the contents of the note, and that's going to be current.contents. Lastly, let's just start the activity. So we're going to say getContext.startActivity, pass along that intent. So now when the user taps that row, they're going to see the contents of the note. Last but not least, we have to make sure we're reloading the notes every time the user comes back. Because remember, that notes list is displaying a preview of the note text. We want to refresh that every time a user finishes editing a note. So to do that, we're going to use a third method. We've seen onCreate and we've seen onPause. We're going to use one more called onResume. So onResume is going to be called every time an activity is brought to the foreground. So when the activity is first created, it's going to call onCreate, and then it's going to call onResume because the activity just entered the foreground. Then we could jump off to some other activity and come back, and then onResume is going to be called again because we're back in the foreground. So this is a great method to reload our recycler view. So rather than reloading the recycler view here in onCreate, we're just going to move this down to onResume. And so this will both reload when the app starts up and every time the user comes back. So now let's give this a shot. Let's run our application. Okay, looks like we have one error here. So it looks like when we call getText, it returns this editable object. So we forgot to just change that to a string. Luckily, that's really easy. We can just say .toString. So let's try running this again. Looks like we built successfully. So here's that recycler view again. Let's tap on a note. And OK, it looks like we got a crash. So let's take a look at our log and see what happened. So we open up our log, and we can see here in red, attempt to read from field on a null object reference. OK, so it even told us it's in Notes Adapter, line 31. So I can actually just click that, and it's going to jump me right to where my exception happened. So it looks like here current is null. Now let's think about this. So it looks like we're setting current in the constructor, but that's not right because when we invoke the constructor is up here in onCreateViewControl on viewholder, but we're actually setting the tag in onBindViewholder. So instead of having this get tag here, we actually want to put it inside of our onClick. So now let's try rerunning the app again. OK, we compiled successfully. Let's try again and tap on this row. And great, so it looks like we've loaded this note from our database. So that worked out. Let's try testing it out by saving the note. So I'm gonna, this is a test note. OK, and I'm going to use the back button to come back to my list. And great, it looks like we've saved it to the database and we've successfully reloaded it in our recycler view. So before we finish up, let's just add some last finishing touches to make our app look a little bit nicer. Let's start with our note activity. So there are a couple things I wanted to change about that edit text. First is it was kind of weird that the text was centered, so let's move the gravity of that text to be at the top. So we're going to set the Android gravity to top. And so now rather than centering that text, that's going to put the text at the top of the edit text. Let's also add a little bit of padding just so the text doesn't run up against the screen. So let's say padding. Let's use 10 pixels for that. Lastly, we had that weird kind of pink bar at the bottom of the edit text. We can get rid of that just by setting the background property. So let's set Android background to be equal to this @Android color transparent. And so that's going to make sure that we have that transparency. OK, so now that our second activity looks a bit nicer, let's come back to that first activity and apply those same changes from our other app. So we're going to set a couple properties. One is going to be make sure it's clickable. So we'll set clickable, focusable to be true. Let's space out the rows a little bit. We'll say Android padding. It's 10 pixels. And lastly, let's add that nice ripple effect, which was foreground. Then you can say Android adder selectable item background. And so this will just make that recycler view look a bit nicer again. So let's take a look at these aesthetic changes by running the app one more time. All right, let's pull up the emulator. So now our row is looking a bit nicer. There's some more padding. If I tap this, I get that nice ripple effect. And then that kind of weird background is gone. So that's it for our Notes app. To recap, we made an app that used a recycler view to display a list of contents from our database, and then we wrote our DAO to save notes, to create notes, and to get them all from the database. And so now you can write Android apps to save settings and other things to the user's phone so they can have them when they open the app again.